Welcome back to the classroom. Today we're going to be looking at the 2015 VCCA physics paper, question 5. Well, it says question 4 there, so it should be question 4, question 5. Question 5. Okay, so for this question, it relates to Module 5, Inquiry Question 2, which is all about circular motion. Okay, another model of car with a mass of 2 kilograms is placed on a banked circular track. The car follows a path of radius 3.0 meters. The motor maintains it at a constant speed of 2 meters per second, as shown in figure 1. The angle of the bank is such that there is no sideways frictional force between the wheels and the track. Okay, so we're assuming we are not dealing with friction. The only thing that is causing this object to go towards the center here is the horizontal component of our normal force. Okay, so that's what we have. All right. On the diagram below, draw the forces acting on the car using solid lines and label each force. Show the resultant force as a dotted line labeled FR. So we have our weight force. I'll write it as FG. You could write it as FW. We have our normal force, which is acting perpendicular to the surface. And then our reaction force. Okay, the resultant force is going in this direction, FR, which is also our centripetal force here. Question 2. Calculate the required angle of the bank of the track in degrees to maintain a 2 kilogram car at 3 meters on a 3 meter circular path with no sideways friction between the wheels and the track. Show your working. So the radius is 3 meters. Let's just make some labels down so we know what we're talking about. Okay, so what we have here, calculate the angle required. Okay, firstly we need to find the centripetal force. So centripetal force is mv squared over r. Mass is 2. Velocity is 3. Radius is 3. So let's look at what our centripetal force is. So 6 newtons. Okay, so back to our force vector diagram. We have our car. We have the acceleration due to gravity or the weight force, and then we have our normal force. Our resultant or centripetal force is drawn on this side here. Okay, and then our gravitational force can be drawn down like so. Okay, the question is asking the required angle of the bank on the track. So that angle is actually, if we change that color again, that angle is the angle we get here. Okay, so what angle is the track causing on this point here? And if we actually have a look, we can actually use tan theta to help us solve the question. So the tan theta opposite over adjacent, the opposite component is centripetal force. The adjacent component is Fg. Okay, so we know that centripetal force is 6. Fg is 2 times 9.8. That's tan theta. Then we go theta equals to inverse tan 6 over 2 times 9.8. And let's see what value we get. Gives us a value of approximately 17.8 0.0 degrees. So that's the angle. So that's the angle of the bank on the track. Okay, and that looks like that completes the question there. All right, so just to end us off, this is actually question 4 of the Victorian paper, 6 marks, so 3 marks there, as you can see from 3 diagrams, or 3 vector arrows, and then us calculating this value of the angle of the bank of our track here. If you found this useful in explaining this exam question, like, subscribe, see you again.